Chapter 1, The Scientific Method, Part 2. What is gravity? And shown here is Isaac Newton. And Isaac Newton is credited with discovering the law of gravity. A picture here illustrates a gravitational attraction situation for celestial bodies. We have the moon, the smaller object, the earth. Of course, this figure is not drawn to scale. The moon would be very much smaller than what the earth here. But there's this notion of a sideways path that the moon has. But because of gravity pulling it towards the center of the earth, it always moves in this circular pattern. If it did not have this sideways velocity, it would fall straight down into the earth. But because it always has that sideways moving velocity, it follows this circular path. Gravity is universal. Gravity is thought to be a universal force because observed stars, systems, and galaxies behave as if influenced by gravity. One, matter appears to be the same throughout the universe. Therefore, gravitational attraction must also be universal. There is no evidence that gravity is not universal. Why is the Earth round? The theory of gravity accounts for the Earth's shape. The Earth is round because gravity squeezes it into a spherical shape. The Earth is not a perfect sphere because its spinning motion causes it to bulge slightly at the equator, the equatorial region, and is flattened at the poles. And that's due strictly to the spinning that it has. It spins one cycle per 24 hours. This is a depiction then of what the Earth would be if it's not completely spherical in some places. Over time, many tens of years, this portion here gets pulled down, flattened out, and a roundness begins to appear. The same here. If this is a hollow region, over time, this rock or sand slides in and fill in the equator, and you begin to have a smoother shaped Earth. The Earth is, as we say, it's not a perfect sphere. It is flattened at the equator region. It's flattened at the poles and bulged at the equator. Tides. The law of gravity successfully explains the occurrence of tides. What is tide? It's the apparent rising of water at a given point on the Earth's surface. So the Earth tides are the result of gravitational attraction of the moon and the sun for the Earth and the water and everything else that's on the surface of the Earth. Coastal areas experience 2 high tides and 2 low tides each day. Why? And we need to understand, why are there 2 high tides and 2 low tides every day? Okay, this is a depiction of what happens. So this is just the moon, this is the Earth, and this is an exaggeration. But notice, because the moon is here, the water on this side of the Earth is bulged towards the moon here, flattened in these areas, less than there, and bulge on the side away from the moon also. The Earth is turning on its axis in this direction. But as it turns, so this would be a high tide at point A and another high tide at point B. But as the Earth spins around and B becomes this point and A becomes that point, then A will experience a high tide when it's on this side, and B will experience a high tide when it's on that side. Therefore, every point then near the coastal region will experience two high tides and two low tides per day. Okay. Neptune, which is the planet that we consider now to be farthest from the sun. Calculation based on the law of gravity predicted the position of an unknown body. The prediction was tested, resulting in the discovery of Neptune. Now, units. Physical measurements consist of a number of units of standard quantities. Standard quantities such as the mile are known as units. The results of every measurement have two parts. It has a number, it has a unit. For instance, 50 kilograms. The 50 is the number, kilograms the unit. For example, 100 miles or 100 meters, etc. They are all two parts to to every measurement, a number and a unit, a number and a unit. The most widely units today are the international units called SI units. Those are the system international or system international units. The basic units then, the unit of time is the second, and we use S. The unit of length is the meter, and we use M. The unit of mass is the kilogram, and we use kilograms. These are the first three that you will get to. That's what we will use mostly in this course. But there are other units. The amount of substance is called a mole, MOLE, and we use MOL as the unit symbol for that. The thermodynamic temperature is the Kelvin and capital K. Electrical currents, ampere, we use capital A, and luminescence intensity, the, the candela is CD. Those are the units that we have in physics. Now I want you to have some awareness of these subdivisions or prefixes. Some of these are more important than others. The hectare is there, 10 to the second. But most important, I want you to know the kilo, which is 10 to the third or 1,000. Mega, which is 10 to the sixth or 1 million. Those are the two that I want you to know on this side mostly. Now, these are then fractions of a length. The center is 10 to the minus 2 or 100th. The milli is 10 to the negative third, which is 1 millionth. The micro is 10 to the negative sixth, which is 1 millionth. And a nano is 10 to the negative 9. And the pico, 10 to the negative 12. These are the symbols that are used for those, as you will see. So I want you to study those and learn these quantities. An example of each being used, 1 kilometer is 10 to the third meter. 1 gigahertz, 10 to the 9 hertz. 1 millimeter, 10 to the negative 3 meters. 1 nanosecond, 10 to the negative 9 seconds, just as an example of some of these. This is an illustration. If this entire length here is 1 kilometer, on a scale, if you consider this length to be 1 kilometer on the scale we're using, then between these two red stripes would be the length of 1 meter. Okay, and now you can magnify it one more time, and now you see that the length here in between these, this is a centimeter. All right, 1 meter. So, and conversion factors are used often in this course as well. And that requires you to be able to multiply. That is all, as you will see as we practice these. 1 meter is equal to 3 times 10, 3.28 feet. or it's equal to 1,000 millimeters or 100 centimeters. 1 kilometer is equal to 1,000 meters or 0.625 miles. 1 mile, 5,280 feet, but it's also equal to 1.609 kilometers. 1 foot is 12 inches, as we all know, and it's the same as 0.305 meters or 30.5 centimeters. 1 day, 24 hours or 8,400 seconds or 30, 3,600 minutes. That's one day. Okay. This is just an illustration of converting. If you start out with a kilometer and want to end up with your answer in nanometers, 1 kilometer is equal to 10 to the 12 nanometers. You can put this nanometer in the numerator over here. Okay. We will have many occasions for this kind of conversion to occur. How long is 878 meters in terms of kilometers and a mile? It is equal to 0.087 kilometers, and you then use the conversion factor between kilometers and miles, which is 0.62, so that the kilometers cancel, you get 0.545 miles. Okay. And lastly, significant figures. We can only trust as many output digits as the input variable with the fewest digits. So if you multiply in two numbers and one number has 3 digits, the other one has 4, then your final answer can only have 3 digits that we can really trust. So three non-zero digits for the most part that we can trust. It is okay to use more digits in the intermediate step, and then we round off to the final number of accepted significant figures in the final answer. Okay. All right. That takes me to the end of this portion. Have a good day.